Let's take a look at this example. I have given I total and Z total. So I can find a very easy voltage source. So if voltage source is equal I total times Z total, where I total is equal 50 milliamps times Z total 3 kiloohms. This is equal 150 volts. Okay, this is my voltage source. Please keep in mind that we want to keep voltage source with angle of 0 degrees. That's why I didn't include any angles in my calculations. Next, I'm going to find R. But don't forget that this is parallel circuit. So in order to find R, I'm going to look first for the conductance. In order to find the conductance, I'm going to find first the total admittance, which is equal to 1 over Z total. This is equal 1 divided by Z total is equal 3 kiloohms. This is equal 333.33 microsiemens. Please notice that the answer is not complete because we're missing the angle. But at this moment we are going to keep going, and later on we are going to find the angle. So next I'm going to find BL, inductive susceptance. 1 over X of L is equal 1 divided by 8 kiloohms and angle of 90 degrees. This is equal 125 microsiemens and angle of negative 90 degrees. This is my inductive susceptance. Next, I'm going to find the capacitive susceptance, BC, 1 over X of C, which is equal 1 divided by 5 kiloohms and angle of negative 90 degrees. This is equal 200 microsiemens and angle of 90 degrees. Okay. Next, I'm going to find the total susceptance. B total is equal BL plus BC. So I have BL 125 microsiemens and angle of negative 90 degrees plus BC 200 microsiemens and angle of 90 degrees. This is equal 75 microsiemens and angle of 90 degrees. Okay, so this is my total susceptance. Now I'm going to find the conductance using the Pythagorean theorem. Someone is going to ask why I'm going to use Pythagorean theorem. Because I do not have angle next to Y total. So in order to visualize what I'm going to do right now, let me draw very quick the admittance diagram. Okay, so what we have so far? We have B total, which has magnitude 75 microsiemens and angle of 90 degrees. So we are going to have phasor which will lay down on the imaginary axis. This is the real axis. Okay, and we found also the total admittance. Okay, so we have total admittance. So this is Y total and this is B total. Okay, so this side of my right triangle, okay, this is my right triangle, is equal to BT, and this is G, my conductance, which I'm looking for, right? So I have Y total and I have B total, so I can find G using the Pythagorean theorem, because right now I'm talking about the right triangle, and this is going to be my angle. Okay, so Pythagorean theorem says that y total raised to the second power is equal G square plus B total square, right? So in order to find G, I have to solve this formula for G, and I'm going to get G is equal square root, and I have y total to the second power minus bt to the second power. This is equal square root, and y total is 333.33 microsiemens raised to the second power minus bt, which is 75 microsiemens raised to the second power. Everything is equal 324.78 microsiemens. Okay, so this is the value of the conductance in my circuit. So next, in order to find the resistance, I'm going to write R is equal 1 over G. So if 1 divided by 324.78 microsiemens, this is equal 3.07 kiloohms. Okay, so this is the resistance in my parallel circuit. Now we are ready to find the angle theta. Okay, so this is the triangle which we obtained in the first part of this video. We said that this is right triangle. So I can find this angle by, let's say, using the inverse cosine. Okay, so inverse cosine of G divided by y total will give me this angle. So I have inverse cosine, and I have G, which is equal 324.78 microsiemens divided by y total 333.33 microsiemens. This is equal 13 degrees. Okay, so this is the angle which I'm going to write next to y total. So if y total is equal 333.33 microsiemens, an angle of 13 degrees. Okay. Now we are ready to find the reactive power. Okay, in order to do so, I'm going to use the formula which says Q, the total reactive power in my parallel circuit, is equal 1/2. Why I'm writing 1/2? Because we are dealing with the peak values. So I have 1/2 voltage source, right, raised to the second power over total reactance. But if you remember, we didn't calculate the total reactance, so we can use the formula which says 1/2 voltage source raised to the second power times B total. So I have 1/2 voltage source, which is equal 150 volts raised to the second power times B total, 75 microsiemens. Everything is equal 800 43.75 millivolt ampere reactive. So this is the reactive power in my parallel circuit. Next, we're supposed to find the power factor. Okay, so power factor is equal to cosine of angle theta. Please notice that this angle which we found is the angle obtained from the admittance diagram. Okay, so most of the time we write letter y next to it. Just make sure that we're not going to confuse with the theta next to z total. So if I have angle theta in my admittance, right, diagram positive, so angle next to z total is going to be with the opposite sign. So I'm going to have negative 13 degrees next to z total. Why? Let me remind you. Z total is equal 1 over y total. So next to 1 I have angle of 0 degrees, and if I have over here 13 degrees, if I'm going to subtract these two angles, I'm going to end up with z total an angle of negative 13 degrees. That's why I'm going to use for my power factor angle of negative 13 degrees. I have cosine of angle negative 13 degrees. This is equal 0.974, and I'm supposed to use word lead. Okay, lead because the total current is going to lead the voltage source by angle of 13 degrees. So how we can get that? Just remember that I total is equal voltage source over Z total, right? So voltage source, we said we want to keep with angle of 0 degrees, and we just found that Z total has angle of what? Negative 13 degrees, right? So I'm going to have I total, right, which is in this case what? 50 milliamps, and 0 minus negative 13 degrees is going to give me 13 degrees. So it shows me that the total current is going to lead the voltage source, which starts at 0 degrees, by 13 degrees. That's why I'm going to write word lead next to the value of the power factor. Now we are going to find the series equivalent circuit. Simply write that Z total is equal 3 coulombs and angle of, we found that next to Z total we are going to have angle negative 13 degrees, right? So I have negative 13 degrees, and convert this value to the rectangular form. Okay, polar form convert to the rectangular form is supposed to obtain 2.92 coulombs minus J 674.86 ohms. Okay, where the real part is my resistance Rs, and the imaginary part is nothing else, just X of Cs. Okay, this is the capacitive reactance because I have negative sign next to J. So we can draw right now the series equivalent circuit, self resistor and capacitor. Okay, so this is resistance, and this is my capacitor Cs. Resistance has value 2.92 coulombs, and because I have given angular velocity, I can find a very easy value of the capacitance. But before I'm going to find the capacitance, I'm going to find the reactive power in my series equivalent circuit. Okay, let me explain you one more time. X of Cs in this case is equal to XCS, okay, because when we were starting solving this problem, we didn't know what reactive component is going to be in the series equivalent circuit. From this calculation, we found that this is going to be capacitors. I can say that X of Cs is equal my X of S, okay? So let's find the total reactive power in the series equivalent circuit. So I have Qs is equal 1/2, and I'm going to use I total square times XCS. Okay, so I have 1/2 times I total, which is 50 milliamps, raised to the second power, times X of CS, 674.86 ohms. QS is equal 843.57 millivolt ampere reactive. This is the reactive power in my series equivalent circuit. Let me remind you that in parallel circuit we got value Q equal 843.75 millivolt ampere reactive. The difference is very small, so we can say that our calculations up to this moment are okay. So next we are ready to find the capacitance of this capacitor. You can use the formula. Let me use this space over here, which says X of C S is equal 1/omega CS. Okay, so solve this formula for CS. So if CS is equal 1 divided by omega X of CS. So if CS is equal 1 divided by omega 1 times 10 to the 5th, of course, radians per second, times X of CS, we found is equal 674.86 ohms. And this is equal 14.81 nanofarads. Okay, so this is the capacitance of my capacitor, 14.81 nanofarads. Okay, so at this moment we can say that the problem is solved.